Okay, so we are now recording. You guys have all made your guesses. Just want to make sure everything is good to go. So we're looking at Edwin's guess, y equals 2/3 x plus 1. And you guys did a really good job on the first one, just for those of you guys who aren't here because I just started recording it. So changing the y-intercept from a 1 to a 2 made the line go through point P, and now we're looking at changing the slope. So watch this. If I take and I draw what Edwin did here, so we'll use orange, and I go up, somebody has their sound up, I think. So if I go up 1, 2, and I go over 1, 2, 3, basically what I've done is I've taken this line and made it steeper, and it will still go through that point, but still have a y-intercept of 1. So, Edwin, nice job. Very nice job. Very good guess. All right, good, you guys. So here's what we're going to look at today. Actually, today, over here. We are going to graph linear equations in two variables. So we're going to look at linear inequalities, not equations. And then we're going to shade the solution area. That always gives people a little bit of problems, so I just wanted to go over it today. And it's in your week's work, so if you get caught up, you'll see it in the week's work. And there's a lesson that goes with it too, so make sure you watch the lesson. A couple things that I want to tell you guys about. The end of quarter one is coming. 2 weeks left. So right now you have a grade in this class, but if you don't turn work in between now and then, or if you don't get to the unit test, what's going to happen is that you will get a 0 on that, and you don't want to get a 0, right? Because what is a 0 going to do to your grade? What do you guys think? It's going to drop it. So you really need to get to the unit test. If you're not able to get past the unit test, even though we're in week 8 and next week is week 9, as long as you get to the unit 1 test, I won't give you zeros for anything in week 6 or 7 or 8. So you guys can do it. I know that some of you guys are really close to it, so just make sure you get to that unit test to avoid getting any zeros. That way, that can actually too also boost your grade and help you rather than give you zeros and hurt your grade. So I want you guys to do awesome. You deserve it, and you want to pass quarter one. Okay. Oh, Marquise, you want to pass quarter one, trust me. Bad things happen if you don't. Like starting over and having to take it all over again. You don't want to take this twice. You want to move on. So you guys check your current grades in IC. Those grades that are in there are current based on current progress and quality of work. Obviously, if you aren't making current progress, each week those grades are going to go down. So, definitely message me, talk to me, whatever you guys need. Okay? Keep daily progress. And then tonight, does everybody know the parent-teacher conferences are tonight? 4 to 6? Okay. And there's dinner. I think that Miss Doran told you guys that. And then pictures are this Friday. So you want to come Friday between 9 and 12 so you can be in the yearbook. And then those of you guys playing sports, like Edwin, I know. Anybody else play a sport or do an activity around? So I think they're going to try to, I don't know if it's Friday or not, but try to get you somehow showing, the football stuff. All right. So anyway, you guys, a couple of key things I wanted to point out. So let's look at our inequalities, like we said, our objectives. Okay. So what we want to do is graph these inequalities. And one thing, raise your hand, you guys, if you have graphed an inequality before. So Emma, you'll just have to raise it on the thingy if you have. So anybody here graph an inequality? You guys? No? Keisha, no? 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 You have? Oh, awesome. I didn't know. An inequality, is it look familiar? That's good. You didn't know what I said? Did you ever graph an inequality? Emma, did you? Have you ever graphed an inequality? Just typing. Gloria, no? Okay. So it's good we're going over this, you guys, but there is a lesson on it. So Emma, I didn't really catch what you typed me. I think you stopped typing. So you guys, the way you graph it is you just graph it like a regular equation. So think of this as y equals 3, okay? The only thing is you have to look at the sign. Notice that this one, is a greater than sign. Now you guys notice, compare that to the one on the right, which is a less than or equal to. You see how it says or equal? anytime you have an or equals like that, you're going to have a solid line. So anytime you have a less than or equal, or you could have a greater than or equal, right? But those will always give you a solid line. And the line that we are graphing is called the boundary line when we're dealing with inequalities. If you just have a less than or a greater than, that's going to be a dashed line. Okay. And these are called boundary lines because they are going to separate the quadrant into two parts. So they're called boundary. Tanya is here. So these are boundary lines. Okay. And again, you guys will see that in the lesson. So when we graph an inequality, what we're going to do is graph and separate the quadrant into two parts. Okay, so on this one, y equals 3, and I put a couple of y equals, x equals type things on here just so that you guys could get a feel for how to graph a real basic, because people get stuck on that and then are able to graph the equations, the linear equation type better. So this is y is greater than 3. So what I'm going to do is I'm going to go to the positive 3 on y right here and put a dot. Okay, and then I'm going to draw my boundary line through that dot. But here's the key. This is a greater than sign. So everybody here, is that going to be a dashed line or a solid line? Dashed. Gloria, what do you think? Dashed. Dashed. Marquise? Emma says dashed. Oh, Keith, you raise your hand. Thanks. Yeah, that's good. So, I don't know. It says you did. And maybe that was accident. So good job, you guys. We're going to do a dashed line through here. Okay, and notice that I draw my line all the way through because that way I'm separating my quadrant into two. So here's the difference between this and a linear equation. So number one, we have boundary lines that are either dashed or solid. And then the second thing is we have to shade the solutions. So when you guys think about that, give me a y that's greater than 3. Give me a y value. Nikita, give me a y value. 4, perfect, good. All right, Gloria, give me a y value. That's greater than 3. Okay, good. All right, Edwin? 10. Okay, and Marquise, I'm not going to go to you because, you know. So good. So anything greater than 3, you guys need a whole bunch. So would that be above this line then or below that line? Above it. Good. So what you want to do then is you want to shade above that line. Because basically what that's saying is any point up there is going to have a y value greater than 3. Good? All right, let's move on to the x one then. So this is x is less than or equal to 5. So again, I'm going to go and I'm going to find 5, but this time on the x-axis. So I'm going to go here and I'm going to put my dot here on 5. And then I'm going to make my boundary line go right through that dot. All right, you guys, big question. Is that going to be a solid line or a dashed line? Oh, nice job. What did you guys say? Solid. Emma said solid. Marquise, what do you think? Solid. Is that black color line or solid line? Dark, a dark line. All right, so you are exactly right. It's going to be all solid black line, although I'll make a blue one because I like colors too. So there's my boundary line. It's going to go all the way through. So then here's the key, you guys. I want all the x values that are less than or equal to 5. All right, Marquise, give me an x value less than or equal to 5. 3. 2. How about 5? Would that work?
5.
And 5. Good job. So is that going to be then to the left or to the right? Which way are you saying? Yeah, very good. So all these values here to the left are all less than 5. So I'm going to shade over there, meaning any point that I choose where that's shaded is going to be an answer. Will work, right? It'll give me an x value less than 5. All right, you guys, so what you're going to be seeing more of, Keys really, I'm watching you. Remember that. Remember that. Yeah, I know. So this bottom one, you guys, is what we're going to see a lot of, and that's just a linear equation. Remember that your 7 is your y-intercept, okay? And then negative 1/3 is your slope. What we're going to do is we're going to plot our y-intercept up here at 7, and then I'm going to find my next point using my slope. So it's negative 1/3. So rise, go down 1, go over 1, 2, 3. Gloria, what are you doing over there? So go down and go 1, 2, 3. Here you typing. Okay, so I made a couple points. All right, solid line or dashed line? Dashed. It's a less than, right? Not a less than or equal to. So I need a dashed line. So what I'm going to do is I'm going to select a nice, beautiful blue dashed line again, and I'm going to try to the straight, but I'm going to go all the way through my grid so that it becomes a boundary line. Okay, so here's where it's a little bit more tricky. I want all my y values, if I look back at the equation, to be less than this function. All right, you guys, I want you to think about this. Okay, really think about it. And I want you to type in your notepad, am I going to shade below or above? So everyone, type in your notepad. I see you typing up above, that's fine too. Okay, so yeah, you got the, or you're still typing. Keith, that is not the right answer. Okay, Donnell, got an answer from you. You're leaving? Oh, yeah, that's fine. Just watch the recording. Yeah, that'll be fine, though. Get out of it. So you didn't even get to answer. Okay. So Nikisha gave me an answer. Donnell. Keith. Emma. Oh, do you shade below or above on this bottom one? Emma, I don't see any answer. Oh, Emma, you did. Yeah, okay, I see your answer. I see you raising your hand, Keith. Yeah. Okay, what do you want? You can, yeah, you can.
No restroom break.
Yeah. Listen to Mr. Kearney. He said no. He said no. All right. Okay, so well, we don't know yet. We're gonna think about it. That people just put. So we got a lot of belows. Donnell's changed it to above. Edwin's above. Emma's a below. Keys is below, and Nikisha's above. Above? Changed it. Okay. All right, you guys think about this. This says y is what? What does that sign say? Do you guys agree less? See how this reads y is less than? So we want all the y's that are less than this function. And this line is the function. So where are the y's less than? Above or below? Hello. So see how it's a little bit tricky?
That's what I said. That's what I was thinking.
No.
He's smart.
He is smart. But Donnell, you gotta always think for yourself. Remember that.
Because honestly, I was going to change, but then everybody started changing, so I was like, oh, no.
Oh yeah, see, then you saw Donnell, and then you guys always think for yourself. Always think for yourself. You just never know. You never know.
Oh, man.
Oh yeah, go ahead, go ahead. That's a bummer. That's such a bummer. I don't know if will that card work on yours or no? Probably not, huh? No. Grab another one. It's fine. You can leave your backpack if you want. Okay. Okay. All right. So anyway, you guys, good job. So what I always, if you can put the equation in this format, then you can always figure out which area to shade. Okay. So, hey Donovan, you just joined us? I'm glad you're here. Haven't seen you lately. We're just doing some inequalities. All right, you guys, what we're going to do is we're going to move on. And so just so you know, Donovan, since you just joined us, this week's lessons have these in them too. So if you missed it, you can watch the lessons. And you can watch the webinar too. All right, next one. So now what we want to do is find out if these points are solutions to this inequality down here. Okay, so how do we know if a point is a solution? Does anyone have any idea what we could do to determine if a point is a solution? Okay, so how would we do that? Good. So Donnell's saying if it's equal to or less than. We could graph it. Very good. We could graph it. That is one way. So let's do that first because that was a really good suggestion, Donnell. I like that. I guess you can come into my webinar as much as you want. So we're going to graph our y-intercept down here at -2. Okay, and then we are going to graph the slope, which is 4. So we're going to go up 1, 2, 3, 4 over 1. Okay, and then I'm going to do one more point. 1, 2, 3, 4 over 1. So I've graphed my slope twice. Marquise, you are back. Very nice. All right. You had a little quick break. So here's the question.
Row.
I'm going to ask Nikisha. Do we want a solid line or a dashed line? Good job. Very good. We want a solid line. Nice job, Nikisha. Nice job. So I'm going to draw a solid line, and that's because it is less than or equal to. So the or equal to means we need a solid line. Oh, I know. I'm off a little bit, huh? Very bad. Don't want to be off. I know it. Thank you, Donna. I'm going to fix my, well, it's not really fixing very well, but you guys get the point. There we go. Inequalities are used to represent, we actually have a problem at the end that will be an everyday real life one. Well, when you're trying to keep track, like for example, companies may manufacture cell phones. And do you think that every cell phone that comes off the line is perfect? No, there's a certain number of cell phones that come off the line with defects, right? But there's no way that's going to be perfect. Just like the post office, right? You think that they are perfect, that they deliver every. Doesn't. I'll talk to you about it. But sometimes they make a mistake. So here's the thing, though. Companies will look at, what is an acceptable amount of mistakes. So that's an inequality, right? Like we can manufacture cell phones with a mistake with maybe, let's just say the color is off between 0.2 and 0.5%, and that's acceptable. But then as soon as we measure that it's off by 0.7%, that's unacceptable, and we need to refigure out our manufacturing line or something like that. Or, for example, when lumber yards cut wood, if you guys like work at Home Depot or something like that, and they are cutting wood to sell it, they'll be okay if maybe you're off. Either maybe it's a little bit too long or too short by 2 centimeters. 2 to 4 centimeters will be the acceptable rate of defect on that. And so, oh good, I must see. I was waiting for you to get back in. There we go. And so, and so in that range, it's okay. But then as soon as you are greater than 4 centimeters or less than 2 centimeters, maybe they'll say, oh, that's not an accurate cut, and we need to retrain you or something like that. So inequalities are used to represent ranges of solutions or ranges of data. All right, so now that everybody's back in, I know, I was waiting for Edwin to see because I didn't want him to miss more because that would be sad. All right, so we graphed our inequality. We knew we had a solid line because we have a less than or equal to sign. So we're going to now shade. So key here, you guys. Am I going to shade up above this line or below the line? And is that your... Well, the solid line means that all those points on the line are equal to, and that's how we capture those. Okay, so think about your response. Oh, here, let me fix you actually. So write what you think. And Edwin, I'm just going to have to give you some rights. And Donovan, I don't think you have rights, so you can just, I'll give you some rights too if you want. And where are you? Donovan. The options. All right, you guys, so everybody has a pod. So everybody put what they think. All right, Edwin, good. I got your guess. Is that your guess? Okay. Huh? What? Oh, no, you don't have to say why. You're good. Yeah, just make a guess if you think it would be above or below. So Donnell says below. Keys, is that your current guess that's up there? Okay. Emma, I see you. Donovan, I don't see you. Donovan, are you with us? Oh, hi, Tanya. I forgot you were there too. Oh, yeah, Tanya, I need to give you some rights. I don't have you with any rights either. Sorry, Tanya. Let me give you some. Let me give you some extra rights. I didn't really forget about you, Tanya. You were just hiding. Well, you weren't hiding, but your name was hiding. Okay, so everybody can type in the note pods now. So hopefully we're all good. Okay, so Tanya says below, Emma says below. So all you guys are saying below. So let's look at it. You have you want all the y's that are less than or equal to. Well, down here right down here. Yep. Those are all less than. And then the equal to, that's what Donnell was talking about over here. Because the line is solid, that means all the points on the line would be solutions to this as well. So let's think about this, because our question is, how do we know if a point is a solution? Well, we can look at this point, 7, 1. Is that fall in our solution area? He says maybe. Donnell says maybe. Yes, yes. I'm getting a lot of yeses, so let's graph it. So 7, 1 is right here. Is that in our shaded area? And granted, I didn't really do a good job of shading it, but yeah, it is. Yeah, it's in our shaded area. Huh? So this is a yes. So yeah, let's look at 3 and 5. Is 3 and 5 in our?
Oh no. No, because it's over at the 5.
Well, but so you go over 3, and then go up 5. Wait, where's 3? 5 right here. Ah, so it still is in there. It's hard to see a little bit. So that is a solution. Okay, now here's a tricky one, you guys. Negative 14, negative 3. Can we see that on the graph? No. So here's the, so you can kind of maybe look, but I'm going to show you guys another way to figure out if a point is a solution, right? So negative 14, is that x or y? X. So negative 3 is y, right? Well, here's my equation. So what if I just plug in negative 3 for y, and then I plug in negative 14 for x, and I see what happens. Okay, so my left side is negative 3. All right, you guys, what's 4 times negative 14? That would be 4 times 4 is 16, carry the 1, so 56, I think. Make sure you guys tell me if I'm wrong. All right, and then let's simplify a little bit more. I'm comparing the left side to the right side. So negative 56 minus 2 is the same thing as plus a negative, right? All right, you guys, negative 3 is less than or equal to negative 58. Is that true or false? Getting a false. False? 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 Good. Negative 3, if you picture it on the number line, is much bigger than negative 58, right? So since this is false, is negative 14, negative 3 a solution? No. It is not a solution because it doesn't work. When you plug it in, it doesn't work.
But that doesn't mean they were asking
So good. So let's answer the question. How do we know if a point is the solution? What's one way? The graph. What's another way? An equation. Just plug it into the equation. Good job, you guys. Good job. Any questions on that one? Nope. Nope. Okay. Good. All right. Okay. So a few more with graphing inequalities. These I just wanted to show you guys just a couple more with the equation just to make sure that you guys were understanding how to plug them in. So if we want to do this one, we just, and notice that, look at our equation, you guys, 3x minus 5y is greater than 12. That would be hard to graph, right? The only way you could graph that, well, that's not the only way, but the way that we know how to graph it is to change it to be in slope-intercept form, to change it to be y is greater than something. So we could do that. We could rewrite it. We could subtract 3x from both sides. We could divide by 5. That just takes a lot of time, and then we make mistakes. You know, maybe we forget to flip the sign, and so then we get an error. So if you get an equation like this, it's a lot easier just to use our second method. So if we plug in a 1 for x, okay, and we plug in a 2 for y, it's a much quicker way. Good. Good. So that's much easier than having to graph it every time. So I plug that in. Is negative 7 greater than 12? Is that true or false? False. So is that point a solution? No, it is not a solution, no. Okay, so let's look at the second one real quick. So we could do the same thing with the second one, and we could just plug it in, and I'll see how you guys feel about this after this one, and if you're good. Okay, so yeah, 9 so plus, remember negative times negative? Be careful about the plus. All right. So true or false? Someone else says true. What do you guys think? True? Is 19 greater than 12?
No,
It's not?
because if you add an 8 to it, it'd be 20. So,
Marquise, are you in the same problem as us?
yeah.
So is 19 a bigger number than 12? Yes, yes, you know that. Do you want to be 19 or do you want to be 12?
I want to be 12. I can get
12?
away with more stuff.
Oh, yeah, but then you're just like little and, you know, people tell you what to do. So how are you guys? Not you. Do you guys have any questions after those two? Do you want to see another one? You good? Emma, it is? Oh, no. Anybody over there, you guys? Tanya, Donovan, anybody need to see the third one? Donovan, do you want to, is that a yes that you want to see the third one or no? Tanya says no. Oh, so Donovan says yes. Okay. Okay, you guys, we'll do it. We'll do it quickly for Donovan. It's totally fine. So, we don't want to write it red yet. Haven't figured that out. Okay, so yeah, so we would just do it like we were doing it before. We're going to plug that in. Good. 3 times negative 5 minus 5 times our y value. And that's going to be greater than 12. And then I'm just going to simplify the left side. 3 times negative 5 is negative 15. Okay, what's a negative times a negative? Positive. Negative 5 times negative 6 is positive 30. And that's going to be greater than 12. Negative 15 plus 30. So see here, Donnell, this is where you have the negative and a positive, so you got to actually subtract. Is 15 greater than 12? Yes. So this is true. And if it's true, is it a solution? Yes. Yay, it's true. Very nice. Very nice, you guys. You think? Do it at the same time. All right. That just about wraps it up, you guys. I just have this one last thing for you guys. And this, you're going to use your note pods on this one. So here's a real life scenario. Okay, you've been sent to McDonald's, right? Your friends send you to McDonald's. And you get orders, and you're gonna purchase chicken nuggets and hamburgers for everyone. Okay, they're like, we're gonna trust you with our money. We're gonna send you to McDonald's.
What type of chicken nuggets are you typing? There's a lot of things from the midnight.
Oh my gosh, I must not have been to McDonald's lately. Go back 20 years. Okay, there's only chicken nuggets, only one kind of hamburger, you guys. I don't know about all those. Oh, or you can make it be. All right, how about this? Big Mac. Big Mac.
All right, all my days. If the Broncos win, if they lose.
They haven't played. It's before their season. Simplifying this, Marquise. Okay, so they gave you 30 bucks. Between everybody gave you money, and you didn't keep track of who gave you what, but you have 30 bucks, okay? And but you wrote down, because you didn't want to get it wrong, because your friends would disown you, that you need 3 chicken nuggets and 5 hamburgers, as Marquise says, the Big Macs. What we want to do is write an inequality, and we're going to graph it. So I'm going to help you guys out here. Here's some questions. We're going to write an equality just like we did before. So depending upon what you put on the left, it's going to be different on the right, and then we can choose our sign. So which one of these, you guys, so write it in your notepad, which one of these A through G, and you can just put A, B, C, D, E, F, or G, you don't have to write the whole thing out, would be the inequality to represent that information. You want one of those choices will represent the fact that your friends want 3 chicken nuggets and you have 5 hamburgers and you have $30. That's all the information you have. You don't know you don't know anything else. You don't know how much chicken nuggets cost. You don't know how much hamburgers or Big Macs or whatever they are cost because you never go to McDonald's. It's 3x plus 5 is the first one. The other one is just 3 plus 5. You can actually
No, not right here.
you can make this full screen if you want.
I don't think I can go here.
Oh, you can go back though afterwards. So if you guys want to look on the full, yeah. So if you want to look on the full screen and then pick your choices, and then type it in your graph. So Edwin made a choice. Nice job, Edwin.
How many people are
Well, there's 8, right? Because we got to order for 3 chicken nuggets and 5 hamburgers. So we do have 8 people.
there? So
Wait, Miss, can we have food yet?
Okay, make 2.
Okay.
You can have 2. If you're not sure, type 2. But you guys don't second guess yourselves. Okay, everybody has to make a choice. Everyone has to pick.
The people in X number?
You could be right.
Why is
You could be right.
okay?
This is like the championship right here, the Super Bowl right here.
Why is the people in X number?
I'm not going to tell you yet. It's a big secret. Just for about 1 more minute until everybody says a guess. All right, so I got Keisha has a guess. Okay, everyone has a guess except for student 2 who didn't type their name, who I don't know. Emma has a guess. Who is student 2 and 3?
I'm 3.
Oh, Marquise, your name is gone. I can't even see you now. Marquise, you choose like almost all of them. E, C, and D, huh? Just to be safe. Gloria's gone. She can't type. You can type for her, but we will not. Emma, good. All right, Tanya. Donovan. Not seeing you guys' guesses. Oh, Tanya, I see you. Very nice. So Tanya has made a guess. Good job, good job. The only one that hasn't guessed is Donovan. What are you doing? Oh no, you're racing Gloria's.
I mean,
Yours is
well, that was the last.
yours
one,
is the first one. Your student 1. All right, Donovan, we don't want to go without you, but we're gonna go.
I think.
Oh, you said E.
All right, who said E? Oh, Donovan. Oh, thanks. I see you up there in the chat. Sorry, I was looking somewhere else. Okay, you guys. So here's what we know, right? We have 3 orders for chicken nuggets, 5 orders for hamburgers, and then we have a dollar amount. Do we know how much the chicken nuggets cost and all that? No, we don't. But we know that if we had 3 orders for chicken nuggets, whatever they cost, let's go to a different color actually. Hang on, you guys. So whatever they cost, 3 times whatever the cost is, so we'll call that X, would give us how much we had to spend to get chicken nuggets, right? Like if they were $10 a piece, that we'd have to spend $30, right? But we also have to buy 5 hamburgers, so we have to add that to 5 hamburgers. Do we know how much the hamburgers cost? No, we do not. We do not. So, but they're going to cost a different amount, right? Chicken nuggets and hamburgers don't usually cost the same amount. So $5 time or 5 orders of hamburgers times whatever they are, $20 a piece would give us the total, right? I know they're not 20. I just made that up. But anyway, so Edwin, I see you erased your other one. Okay, the E is exactly right. Good job. So it looks like, Nikisha, you put an E in there. Everybody is doing an E.
Oh, I thought we were doing the whole
Oh, Marquise, you're getting ahead. Nice job. The dance. So you guys, good job. E. Okay. Now let's actually skip our choices in the middle for a minute and go to the right. What would the right side be then? Which of these choices, A through G, would be on the right side? What would you guys put? What are we comparing this to? La, la, la. So we need something on the right side of our inequality. So Emma, good. I think that's your current answer. I see you. You're thinking A or G, or is that your old answer? I think that's your old answer. Sorry, Emma. D's, what are you thinking? D? F? Emma, you erased everything. You're invisible. What do you guys think? Nikisha, did you put a D? Okay. Edwin, are you a D? All right, so I've got 3 D's actually. Tanya's a D. All right, you guys, let's look at D. So D is 30. So let's think about if that's right. Are we comparing then? So if we think about what we have on the left, if we have 3 chicken nuggets times how much they cost, plus 5 hamburgers times how much they cost, are we going to get a total dollar amount right there? Yep. And so we would compare that total dollar amount with how much we have, and we have $30. So what should our inequality sign be in here? A, B, C, or D? There's no F. Not in the middle one. What do you guys think for our inequality sign? Oh, look at C. I wrote him weird. Yeah, you guys, C is a less than or equal to. Is that what you think?
It's less than or equal.
You're going to change that answer? Okay.
I'd say less than.
You're saying less than or equal to? Oh, I think so. Donovan, you are not responding. Emma said C then. Donovan is MIA. Oh, no, you're not. I see you typing. Good. Thought maybe I lost you or something. Okay, so we'll see what Donovan says, and then we'll determine if C is correct. You don't, I think you're trying to say you don't feel good. All right, you guys. Donovan's continuing to type. I'll read you in a second. So C is less than or equal to, does that make sense then? However much it costs, better be less than or equal to what I have in my hand, right? Okay, good. Perfect, you guys. Nice job. So if we graph this, here's a situation where, like I said, this is going to be hard to graph like this. So what I'm going to do is I'm going to switch it. I mean, we could do it. We could make a table of values. But what I'm going to do is show you guys how to switch this to slope-intercept form, and then we will just graph it and be done. So 5y is less than or equal to negative 3x plus 30. So I subtracted the 3x to the other side. Now I'm going to divide everything by 5. What you have to be careful of on the right side is that you have to divide everything by 5, every term. Okay, so be really careful about that. So what I'm going to be left with then is y is less than or equal to, here's my slope, negative 3 over 5x plus 6. All right, so what I'm going to do is I'm going to plot my 6 at my y-intercept, and then my slope is a negative 3/5. So I'm going to go down 1, 2, 3, and then over to the right, 1, 2, 3, 4, 5. Okay, you guys, solid or dashed line? This one. Solid or dashed? Solid. Solid, yeah, because it's less than or equal. So there you guys go. Am I going to shade above or below? Below. I want all my y's that are less than or equal to. So you guys, what does that tell us? It says, what if you get to McDonald's and you discover, here's what you discover, the price for the chicken nuggets is $3 and the price for the hamburger is $5. So let's make some points here. So here's what I find, right? 3 for my chicken nuggets and 5, look, it matches how much I'm going to order. And 5 for the hamburgers. So let's plot 3, 5. 3 and 5 is right here. Can I afford to buy the chicken nuggets and the hamburgers? No. That point is out here, outside my solution area, so that will not work. What if I discover that the price for, you guys, how much are chicken nuggets? I'm going to just say they're $2. How about that? A 4-pack, exactly. How much is a hamburger? A Whopper. Oh, that's Burger King. A Big Mac. What's a Big Mac?
Like $5 or $7. 5, I think.
Let's just pretend like they're only 4, because that is crazy.
It's like 4
We're just going to go with the 4, you guys. All right, well, here we go. Can I afford to buy them their food if the chicken nuggets are $2 and the McDonald's things are 4? Can I buy them? You guys see that on the graph? Keisha says yes. Keisha's good. You are right. All right, you guys. Any questions? Any questions? No? No? Marquise?
No.
All right, Donovan, that's fine. So no questions over there? All right, Emma, awesome. All right, guys, so here's what we practiced today: graphing linear equations in two variables and shading the solution area. So go ahead and rewatch any of the instruction in the week if you need help, but that concludes our webinar for today. And
How'd I do?